Good morning, physics honors. I'm going to take a moment to kind of go over some questions that you may have encountered going through this week. This will kind of relate to some of the questions that we talked about, or that we didn't talk about since we're not talking at all, but that I asked you to take a look at in your assignment and that they would have talked about in the videos. I did try to make these pretty close to the kind of stuff you would have seen in the video. So just let me know how that's going. Again, I received a few questions, very few of them, but I did receive some responses already. And in looking at those responses, there's some things I can take a look at to know kind of things that you're not necessarily struggling with, but that you didn't get in terms of how the math is working here. So I just want to go over that with you. Please try to make sure that you are communicating with me as often as possible. Again, I can't help you out if you don't let me know what you need help with, but I understand that. So just kind of let me know what you need and don't need. All right. So we're working with circles. Cool. We got a little circle here. So on the circle, what we're going to have is we're going to have a weight. Let's just say it's a box. And it's going to be on the outside edge of this circle. And this circle is going to have a radius of 2 meters. And this mass of this box is going to stay 4 kilograms. And we're going to do 2 different problems here. And those 2 things are going to stay the same. So on the first problem is going to be a little different from what I asked you to do, but it's a good thing to review because it might come up. We're supposed to be learning, not just supposed to be like, what do we need to get tested on? Remember, education is supposed to be about more than that. Blah, 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 blah. I don't need to rant to you on a video. So anyways, what we're going to do is on the first one, we will know how fast it is going here, right? So we're going to know. We're going to know that it's going 15 meters per second. Cool. 15 meters per second. So the next thing we're going to know is that it's going to want us to solve for what is the centripetal force here. Now, the centripetal force here is going to be provided by this rope. And it's going to stay the same the whole time. And how do I know it's going to stay the same the whole time? Well, because my acceleration, or my velocity here is going to stay the same the whole time. If my velocity changed, then my centripetal force would change. If I speed up, it's going to get bigger. If I slow down, it's going to get smaller. So I know that my centripetal force stays the same the whole time. Now, that does not mean that the force that the rope provides is the same the entire time. It just means that the centripetal force is the same the entire time. What's the difference? Well, the centripetal force is what is the overall force that points in towards the circle. The overall force that points in. It's kind of like our net force, like we had in linear or one-dimensional, two-dimensional physics, right? So in this case, it's the overall force. So this rope is providing that force here. And we can say that it provides the overall force, but let's say that I do that in like a vertical loop. Well, we know that gravity is also interacting with that thing. So at certain times it's pulling towards the circle, and at certain times it's pulling away from the circle. So that means that those forces do change, even though the overall force stays the same, right? So again, we can see that those are changes. That's not going to happen here. We don't need to know that. We're just dealing with centripetal force, the overall force, which again is staying the same. And it's staying the same. We know that because our velocity stays the same. So we're going to go to Newton's second law, which says that the centripetal force is mass times the centripetal acceleration. What we do have to know is that our centripetal acceleration is our velocity squared over our radius. And again, you have to know what those 2 things represent, but the radius is just the distance from the inside of the circle to the outside where our weight is being swung around. Cool. And that means that we can put that into our equation and pretty simply go through and solve that. We can say, okay, force is equal to mass times velocity squared over the radius, which means that my centripetal force must be 4 kilograms times 15 meters per second squared over 2 meters. Cool. I'm going to get that close so that you can see it. Cool. So 4 kilograms times 15 meters per second squared over 2 meters. That is my mass times my velocity squared over my radius. Cool. And so if we do 15 squared is going to be 225. I just happen to know that. You don't have to have that memorized, but 15 squared is 225. We divide 225 by 2. That gives me 112.5. If you multiply 112.5 times 4, that gives you 450 newtons. Yeah? Yeah. 450 newtons. That's how much force is provided by that rope in that situation, right? Well, that's the overall centripetal force. We're going to just go ahead and say that the rope is providing that force the entire time, but again, if you need an explanation on that, you can literally rewind. I just went over it. Okay. So let's do one that's a little more like what you're going to be doing in the question I asked you this week. Now, that doesn't mean that we're not going to have other questions. We're probably going to move on from doing this stuff this week. We'll probably move on to gravitation. but gravitation is just a reiteration of this idea. Cool. So let's take a look at one where something changes, where we don't know the velocity, and in fact they want us to find it. So let's say that they tell us our centripetal force instead. And let's say that our centripetal force is 100 newtons. And I'll get rid of this little trailing part here so that there's less confusion. Cool. 100 newtons. Right? That's our centripetal force. We know that. Now we don't know what our centripetal acceleration is, and we don't know what our velocity is. Those are the things that we no longer know. Right? So, again, our radius and our mass stay the same from the previous problem. Cool. So let's say that they asked us, can we find that centripetal acceleration? Well, that just requires us to realize that we already have everything we need. We're going to go back to Newton's second law. And when we take a look at that, what we'll see is that it's pretty easy for us to go ahead and find this number. So Newton's second law tells us that the centripetal force is equal to mass times our acceleration. It stays the same, right? It stays the same as when we were looking at it previously, except now again we have these little labels and our definition of acceleration changes. But pretty much the same. And so that means that if we divide the mass out, take our force, divide the mass out of it, then we'll get our centripetal acceleration, right? So we'll go ahead and plug our numbers in for that. So when we do that, we get 100 divided by 4 is centripetal acceleration, which means 25 meters per second squared is my centripetal acceleration. Cool. So again, we have 100 newtons is my force, and we plug that in there, and then we have 4 kilograms, which we got from up there, is going to be my centripetal, or my mass, excuse me, and therefore my centripetal acceleration is 25. 100 over 4 is really easy, right? So no big deal there. Cool. So you get there 25 meters per second squared. Now, if you're wondering why is it meters per second squared, this is something we've covered already, but remember this is going to be up here newtons divided by meters. This is 100 newtons divided by meters, and newtons is kilograms times meters per second squared. Now that's, excuse me, newtons over kilograms. I thought meters because this is mass, and I was thinking m is mass, and I apologize for that. But so here we have, this is actually 4 kilograms, right? So this is 100 newtons divided by 4 kilograms. And we take the kilograms out of newtons, we end up with meters per second squared. Okay. So let's say then again, we want to find out what is my velocity. Well, we're going to take that number we just got, that 25 meters per second squared, which is my centripetal acceleration. We got that 25 meters per second squared, which is my centripetal acceleration, and then we remember that my centripetal acceleration has a definition. That's velocity squared over the radius, right? Velocity squared over the radius is centripetal acceleration. So now I have a definition, two things, where I have two different definitions of the same thing, right? I have acceleration, two different definitions of the same thing. And so we can set those two things equal to each other. And we're going to get 25 meters per second squared is equal to velocity squared over r. So we set our 25 meters per second squared equal to that. Now our r is 2. So all we have to do is come up here. We're going to take the r out. And we're going to put in 2 meters. Because we know that it's 2 meters. And then all we have to do is algebra to solve for what is v. So the first thing we're going to do is multiply 2 meters each side. And we're going to do that because we're dividing here. And we want to undo that, right? So that gives us 50 meters squared over second squared is equal to velocity squared. So we get 50 meters squared over second squared is equal to velocity squared. Now, why is it meters squared over second squared? Because this over here, this 2, right? That's 2 meters. So when I multiply each side by that, I multiply the meters in there as well, right? So meters squared over second squared. That means that when I get ready to do this, which is take the square root of both sides, because I'm going to undo this squared, that's going to give me meters over seconds, which is what I want, because that's velocity, right? We're going to leave it as square root of 50. And that's going to be meters per second is equal to velocity. I'm going to leave it as square root of 50 because that's simple and I don't have to use a calculator doing that, right? Square root of 50. But if you want a better number, it's going to be really close to 7. 7 times 7 is 49. So we know square root of 50 is really close to 7. Cool. So again, I didn't really get a lot of questions this week. I will be available today for a meeting on Google Meet, which I'm not going to post here because this is a public video and I don't want random people showing up. But yeah, I'll be available today. I don't know if anybody will show up. Again, I'm having a hard time communicating with you guys because I don't know what it is that you need or don't need. I'm not getting a lot of feedback. I am getting some of your assignments, which is nice, and obviously keep up with that. But not a requirement. But in terms of like knowing what's going on with you, I don't have a lot of input for that. So just let me know. There's a short little video for you.